Good afternoon, everybody. Welcome to Wednesday afternoon at Chem 170 with your host, me, Dr. White. Hi, everybody. All right, let me remind, oops. What did I just do? Hold on one second. There, it went away. Press one of the buttons and all of a sudden something I've never done that before. All right, let me remind you, after we finish today's lab, which because we're actually a little ahead of the schedule, I'll lecture for 50 minutes. We'll take a 5-minute break. We'll do the lab, and then I'll send out the password for test number 2. You have until tomorrow, either 1 or 4 p.m. I don't remember which, probably 4 p.m. to take test number 2, upload it as a single PDF file to D2L, just like you've been doing your labs in test number 1. By Sunday, 1 p.m., I guarantee that I will have the scores, your test scores, in D2L. By Sunday, 1 p.m., probably both will be earlier, but I guarantee by 1 p.m. Sunday, even if I have to stay up all night Saturday, that won't happen. I'll get it done in time. I will also send out an individual email to each of you with the points you receive for each answer on test number 2. Next Monday, I will go through test number 2 answers, but I'll cut it out of video. I like my special effects. And I will post it as a private YouTube video. And by Tuesday morning at the latest, I'll send each of you an individual email with the URL for that private video. Now, if you don't have a printer, let me remind you, you can just go ahead, write the answers. You don't have to write the questions on a piece of paper. Be sure to put your name and scan that or use your cell phone to make a single PDF file. Any questions about test number 2? All right. Well, in that case, let's get to work. Material I'm going to talk about now won't be on test number 2. It'll be on test number 3. Where's this semester is really moving along quickly. Well, time flies when you're having fun with organic chemistry and Dr. White. All right. On Monday, I talked about the reaction of a carboxylic acid with sodium bicarbonate. And here's general reaction. We already went through this. And remember, I talked about the rocket ship where the carboxylic acid was acetic acid, and that's found in vinegar. And my father showed me with the little cap from the toy rocket, which had the awful candy in there. I mean, it was bad. The build-up pressure and the cap would fire off, and it looked like you just had a launch for your own rocket. And when you're 6 years old, that's amazing. It's cool. In fact, I don't know if I told you this, I have a photographic memory, and I can close my eyes. I can see me and my best friend at that time, Dickie Dale, out in by our apartment. I lived in an apartment in Chicago. We were outside, and we were doing that. It was fun. All right, let's move on. A couple interesting things. Why are you learning this stuff? Well, I'll teach you later how you make this. Well, I did already. If you take benzoic acid, react it with sodium hydroxide, you get sodium benzoate, this compound. Switches off for this slide, but it's still interesting. And this, or potassium, mainly sodium, if you look at a can or bottle of pop, you'll see near the end that it's, guess what? On the ingredients label, it's a preservative. What it does, I don't know, I'm an organic chemist, but it is there. Now, another interesting molecule is if you go to the bakery and buy or supermarket and buy a loaf of bread, and the next day you get up and go to cut a piece of bread. Good news, you're not going to see any mold or icky stuff, that's scientific icky stuff, growing on the bread. That's because they put this molecule called calcium propionate in the bread as a preservative. Now, I'll teach you later on, other carboxylate anions are used at things such as soap. If you have bar soap at home, which I do, I don't like for my shower, liquid soap. For washing my hands, liquid soap. And I'll teach you about both, but carboxylate salts or anions are used as soap. We'll cover that later in the semester. All right, switch is on. How do you prepare carboxylic acids? Notice I've gotten to slang in chemical industry, we just call them acids or other types. All right, the first one is you can oxidize a primary alcohol. And when you do that, you get a carboxylic acid. So if you take a primary alcohol, and remember, this means an oxidation reagent, you'll get a carboxylic acid. Now you might be saying, well, wait, Dr. White, for ketones and aldehydes, you take a primary alcohol and you get an aldehyde. And for test 2, that's true. But depending on the oxidation reagent, how strong it is, and reaction conditions like temperature, you'll see why in the next reaction, why this is also happens. So let's take a look at this. If I take a primary alcohol and oxidize it, what do I get? Well, you look for what's different. What's not carbon, what's not hydrogen should get your attention real quick, or a carbon-carbon single bond. OH on a carbon, since I'm oxidizing it, I'll write it as a primary alcohol. And for this chapter, for test 3, you will get a carboxylic acid. And what's my R group? This. The other way of thinking is you start with 3 carbons. Do you break carbon-carbon single bonds? No, you better end up with 3. So I have my R group, my 2 carbons. This carbon becomes the carbonyl carbon, carbon double bond oxygen. And you make this carboxylic acid. Now, something I should share the fun. Your turn. What would be the organic product or products for the following reaction? 3 points each. When you're done, don't forget to vote. And for those of you done early, you've heard me say this already, please be patient. Everybody's done, my turn. If I look, what's different, what's not carbon, what's not hydrogen? Ooh, oxygen and hydrogen on a carbon, with carbon's here. Oxidizing it, that's what O in the brackets means. So I'll write it this way, a primary alcohol. And when I oxidize that, you get a carboxylic acid. Both this reaction and the other one I'll show you in a little while, and one I did in ketones, aldehydes, I use these oxidation reactions in my PhD thesis research to make certain compounds like carboxylic acids. So what's R? And it's got 3 across and a methyl there. And then this carbon is this carbon is this carbon, which is this carbon. And I have 5 carbons. I have 5 carbons. So now I put in the hydrogens. And I know there are 4 bonds to carbon. And I'm done. I made that carboxylic acid. Now, on test 3, like test 2, I'll have 3 or 4 synthesis problems. And the question would be, give the starting material that you oxidize to make that molecule. Your turn. And I'd like to thank all of you coming to my class today. It's a pleasure having you all. All right, my turn. Now, how do you do this? Well, in this case, you look at the product, what's different, what's not carbon, what's not hydrogen, get your attention. Ooh, carbonyl hydroxyl group, R, carboxylic acid. And what do I oxidize? Well, for this example, a primary alcohol. And if you excuse me, I think I'm about to sneeze. Hold on. Because I was wrong. I stifled my sneeze. So what's our R group? Oops. This T-butyl. And then this carbon, which is this carbon, becomes this carbon. So I'll add it, and that's an alcohol. And I know there are 4 bonds to carbon. And that's the molecule. If you oxidize it, you'll get that carboxylic acid. Oh, this is fun. Let's do another one. What would be the product if I reacted this chemical or oxidized it? What would I get? Your turn. And if you see my head, I'm looking at the poll results. So I know when everybody has said, yes, I'm done. And everybody said, yes, I'm done. My turn. If we look at this molecule, what's different? Oh, I've got an oxygen that got my attention with a hydrogen and a carbon. This is an alcohol. But since I'm oxidizing it, that's what this means. I'll get a carboxylic acid. What's our methyl? This carbon becomes this carbon, will become this carbon. And that's my product. Now, I have something to ask you, so I will. Anybody see the significance of this reaction? I'll give you 15 seconds to think about it. I'll give you a bonus 5 seconds. All right, my turn. What's this molecule? Ethanol. What's this molecule? Acetic acid. And where do you find that? In vinegar. Now, this is the wine lover's nightmare reaction. Why? Because if you have ethanol, like in wine, and air will oxidize things over a long time, very slowly, you'll make acetic acid. And guess what? The wine will taste like vinegar. How many of you have ever been with people and you open up an expensive bottle of wine and you taste it or smell it? Oh, this bottle went bad. That's because when they corked it in the old days, now they do screw top for the cheaper wines, but the good wines use cork still. Air got in there, and the ethanol is oxidized to acetic acid, and bad wine tastes like vinegar. Actually, Dr. White, most French wines taste like vinegar. I'm not a French wine person. German wines, yes. French, no. Now, many, many years ago, one of my fraternity brothers got his degree when it was still pretty new in computer programming, computer science. And he was really good. I haven't seen him in a number of years, but he was a really good programmer. Well, it turns out that he was hired by some new banks that were in the Caribbean, Bahamas. And they paid him a lot of money to help set up the software to run their bank, because that was all new stuff. And boy, he was rolling in money. And at that time, he still lived in Chicago. Eventually, the banks convinced him, gave him a lot of money to move down there. And he lived there for a number of years. I think he's back in Chicago and there. I don't know, we've lost touch. But he was a wine connoisseur. And when you have money and you're a wine connoisseur, you can go out and buy $100, $200 bottles of wine. And he had a big wine rack in his condo. This is when he had a condo in Chicago. And after a while, he had his wine rack totally full. So he'd invite some friends over to have a wine tasting party to use some bottle of wines so he could go out and buy some more bottles of wine. Nice when you're rolling in money. And he was. Well, anyways, I remember one wine tasting. He opens this really expensive bottle of wine. We poured, vinegar. He said, oh no, it went bad. Well, that's chemistry, organic chemistry. Now, let's look at this reaction again. Can anybody consider who is the largest purchaser of ethanol in the United States? Nope, it's not a company that makes vodka or other hard spirits or alcoholic drinks. No, it's this company called Heinz. Heinz? Yes. And one of their products is, and let's see if you can see this. As you see here, ketchup. I've got a bottle of their Simply ketchup in my refrigerator. I also like the KC Masterpiece barbecue sauce too. See, I told you to learn a lot about Dr. White. And if you look at here, concentrate from red ripe tomatoes. I'm glad they don't use green tomato. No. And then distilled vinegar. And also, if you go to the supermarket, you can buy one of the brands, Heinz vinegar. And how do they make this? And also they sell mustard, which has vinegar in it, and pickles that has vinegar in them. And the question is, how do they make the vinegar? And they make their own. Well, in the older days, they used to take ethanol and chemically oxidize it, like I just showed you, to acetic acid, and they get their vinegar for their vinegar they sell, use that vinegar to make their ketchup, their mustard, and pickles. And I guess they make relish too. How many of you have the atomic green relish, the relish that glows in the dark that we use here in Chicagoland? I've got it in my refrigerator. A number of companies make that. But anyways, nowadays it's cheaper and more environmentally friendly. They found certain microbes that they chemically, but in the microbe, consume ethanol and oxidize it to acetic acid. It's biochem. I think that's cool too, just not an area I've worked in. All right, let's move on. Now, you can oxidize a primary alcohol to a carboxylic acid. Remember, for today's test, primary alcohol is oxidized to an aldehyde. Now, you can also oxidize an aldehyde to a carboxylic acid. And This is why a primary alcohol, you oxidize the aldehyde, and if you use a strong enough oxidizing reagent, it goes through the aldehyde and keeps on going all the way to the carboxylic acid. And I've used this reaction when I was doing my PhD thesis to make certain molecules I had as aldehydes into carboxylic acids. And here's the general reaction. If I take this aldehyde and reoxidize it, that's what O in a bracket means. What do I get? Well, this is an aldehyde, it's a simple one. This is R. And you oxidize it into a carboxylic acid. If this is R, remember you don't break carbon-carbon single bonds, and then I'll get my carboxylic acid. And now I'll let you try one. And here's one for you to try. What? Oh, no, don't look. Sorry. Now it's your turn. What product or products do you get from that chemical reaction? All right, let's look at this. Look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention like that. That'll help you with today's test too. And I have oxygen, carbonyl, hydrogen on the carbonyl carbon, R group, this is an aldehyde. If I oxidize it, I will get a carboxylic acid. What's my R group? This. So I know it's going to come along for the ride. In other words, do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 2 methyls. It's attached to this carbon, which is this carbon, becomes this carbon. I know there are 4 bonds to carbon. And that's what you get. Hold on, I might have moved too quickly in case somebody was checking. Did you get it right? I hope so. Now, we will have synthesis problems on test 3. Remember, the material I'm going over now will be on test 3. And what would you oxidize to make that compound? Your turn. All right, my turn. How do you find out? What do you react? And synthesis is the fun part of organic chemistry. But I'm biased. I'm a synthetic organic chemist. Remember, synthesis means to make. Well, you look for what's different, what's not carbon, what's not hydrogen. Ooh, carbon double bond to oxygen, same carbon has a hydroxyl group. And we've got carbons here, which I'll call R, carboxylic acid. And what do you start with? An aldehyde. Now, in real life, I'll probably never put this as a synthesis because you could also put down an alcohol here. But for this class, well, let's do an aldehyde. So I have 4 carbons, my R group, plus this methyl. And then I have this carbonyl, which is an aldehyde. I know there are 4 bonds to carbon. And that's what we start with. You oxidize this molecule, you'll get this. And a quick check, 1, 2, 3, 4, 5 across. 1, 2, 3, 4, 5 across. This methyl is on the 3rd carbon. Remember, this is carbon 1. And I did it right. By the way, think about it. 6 months ago, if I said this methyl group, would you even know what I was talking about? Boy, isn't it amazing how much you've learned? Oh, let's do another one. Now, let me point out, a benzene ring will not be oxidized. It can't be oxidized. You can try it, it won't. But what would be the product or products of that reaction? All right. Now, if we look at this, what's different? What's not hydrogen? What's not carbon? Oh, oxygen, double bond to carbon, carbonyl with a hydrogen and a benzene ring is this R. And aldehyde. And when you oxidize it, you get a carboxylic acid. So my R group is a benzene ring. And I'll get this carboxylic acid. Now, I'd never ask you to name things in a reaction, but I will today. Not you, me. You start with benzaldehyde and you make benzoic acid. That's the common, which became the IUPAC name for this molecule. Now, this is a liquid at room temperature. This is a white solid at room temperature. And why am I telling you this? Remember the lab with aromatic compounds where if we had been face to face, I asked you to smell things, but since we're not face to face, I told you benzaldehyde smells like almonds and cherries. You can smell, I can smell both. Some people only smell almonds, some only cherries. Whenever I drink Dr. Pepper, which I like, I think of benzaldehyde. If I have almonds, I also think of benzaldehyde. Or, amaretto. Good stuff. I've got a big bottle in my liquor cabinet downstairs. But the reason I'm telling you this is if we were in a lab, when you take the bottle of benzaldehyde, you'd see if I haven't taken it off, Dr. Daly or I, you close the bottle, screw cap bottle, and then you wrap what's called paraffin. And this is a material that stretches, that forms a seal around the top of the bottle and the cap that air can't get into. Air has oxygen. And when you take that cap off, even with the parafilm on there, the liquid, the bottle of benzaldehyde, which is a liquid, you'll see on the screws of the cap of the bottle, a white solid. And what is that? Well, if there's any benzaldehyde, when you're pouring a drop or two, got on the screws of the bottle where you put the cap on, the air with time, the oxygen oxidizes benzaldehyde to benzoic acid. And you see that white solid. Neat. Sometimes not really. All right. Now, let's talk about a really cool, and I mean really cool, reaction. That's making a carboxylic acid with a Grignard reagent. By the way, this H+, I should have what? H+ / H2O. Sorry. So, and this is a really cool reaction. If you take a Grignard reagent and react it with carbon dioxide, CO2, second step, add acid water, you'll make a carboxylic acid that's one carbon atom longer than the R group you started with. You made a carbon-carbon single bond. Again, when you do this reaction, you make a carboxylic acid that's one carbon longer than the R group you started with. And this carbonyl carbon is bonded to the carbon in R that has the Grignard magnesium halide bonded to it. Oops, it helps I put the CO2 there. Ouch. All right, and you don't, the order of reactants in a reaction doesn't matter. So what's different here? Carbon, magnesium halide, a Grignard. And I have CO2. And second step, water and acid or acid and water. And you make a carboxylic acid that's one carbon longer than the R group you start with. What's R? Ethyl, 2 carbons. With this reaction, I'm going to get, this is going to attach to that. And I get 3 carbons in this molecule. And this is one of those special reactions, which is also why Victor Grignard won the Nobel Prize in chemistry. It's 1 carbon longer. Now, I'm going to have some fun, Dr. White's way of having fun. How does this happen? Normally, I don't show mechanisms, but this is a cool mechanism. Now, if I write the CO2 like this, and if I were in a class, I cover my hand over one of the oxygens. Hold on. You see, I've got it covered over one of the, no, it doesn't work. But this is a carbonyl. And you know, Grignards react with carbonyl. Now I'm really having fun. And what you get is this carboxylate anion. And when you add acid and water, this is a base, this is an acid, you protonate it, and you get your carboxylic acid. Oh, that was fun. This will never be on a test. Now, I should point out, every reaction I show you, I can do the mechanism. That's part of my training. And also my research advisor, who I was in his research group to get my PhD, Dr. William Roosh, who I will ever be grateful for, that he beaten to all of us, know the mechanisms. All right. Now, why do I call this a really cool reaction? One, it allows you to make a carbon-carbon single bond. But in the lab, you take ether as a solvent, make the Grignard, which you learned how to do, and you put in dry ice. And that's why it's cool, because if you ever work with dry ice, it's minus 72 degrees centigrade. And with that, what would be the organic product or product for the following reaction? Wow, you people are really getting the hang of this. Thank you. All right. What's different? Ooh, magnesium chloride on a carbon, a Grignard reagent. And X can be chlorine, which in our case it is, bromine, or iodine. And we're reacting with carbon dioxide, second step acid, that's what the H plus is, and water. And you'll get a carboxylic acid that's 1 carbon longer than the R group we started with. What's the R group? This. 4 carbons. I'm not going to break carbon-carbon single bonds. I end up with 4. Now, the carbon with the Grignard is the carbon bonded to this, the carboxylic acid. Now, this is one way of writing the product. I could have also written it this way. And these are the same molecule. Now, let's do one more. This is fun. And there's some fun for you to have. What would be the product of products for the following reaction? With this reaction, I will not put a synthesis problem. That's not nice. And by now, I hope you know Dr. White likes to be nice. And let me remind you, during tonight's test, or when you're taking it, from about 4:30 till about 9, every couple hours, I'll check my email. I have my office hour tonight from 6 to 7:15. If you have any questions, email me or come to my office hour. You can come and say hello. That's always enjoyable. Spend time with students like that. Also, tomorrow morning, till about 8:30, I'll check my email once or twice. And I have a dentist appointment I have to go to. Ouch. But I probably will be home about 11:30. And by noon, I'll check it a couple times before you have to hand it in. All right. What do we have that's going on here? We look for what's different. Ooh, what's not carbon? What's not hydrogen? Magnesium iodine and a carbon. This is a Grignard. And X can be chlorine, bromine, iodide. Our case is iodine. And this is my R group. I'm reacting with carbon dioxide, second step, acid and water, and I'll make a carboxylic acid that's one carbon longer than the R group you started with. You made a carbon-carbon single bond. Very special, very rare. Do you break carbon-carbon single bonds? No. So I'll have my ring, my methyl group here, and this carbon will become, this is my R group, and the carbon in R is the carbon that this is bonded to, the carboxylic acid, carbonyl. And this allows you very easily to make this type of carboxylic acid. I can easily make this Grignard, and without this reaction, I don't know how I'd make that reaction, that product. Now, I'm going to go a couple minutes since our break, and then we'll take a break because you can get out early anyways today. And let's move on. And what are we moving on to? Oh, no, it's time for a new functional group. New functional group time. And those are carboxylic acid derivatives. Those are carbon compounds in which the hydroxyl group, and I'll never ask you what a carboxylic acid derivative is. Derivative means derived from, made from a carboxylic acid, are replaced by various other groups. And I should mention in this section, I'll tell you about something that smells, some things that smell really good. I'll also tell you a story I'm not too proud about what happens when I was in high school and I got into the doghouse with my mother, which in high school, especially when I was a freshman and sophomore, I could easily. So could my other friends too, with their mothers. Now, the real functional group we're going to talk about is an ester. And an ester is an R group, carbonyl, O like a carboxylic acid, but the hydrogen is replaced by carbons we call R prime. This is an ester. Now, that's really what we're going to talk about. And another one, too, we've mentioned. Now, we can have, which I've worked with heavily, acid halides. Like if X here can be chlorine, bromine, or iodine. Mostly it's chlorine, and that'd be an acid chloride. We saw that in Friedel-Crafts acylation. I just don't have the time to talk about that. We will talk about esters. And esters are derived from carboxylic acids. That's where you replace the hydroxyl group with OR prime. And so an ester looks like this. And if I were to draw an ester, here's my R group, here's my R prime. This is an ester. Now, cute story. This happened at the other school I teach at, and I teach organic there too, not this semester, but I do. A number of semesters ago, I had a student named Esther. That's the only time I've ever had that happen. And when I was doing this chapter, I could see out of the corner of my eye, said, all right, we're going to talk about this Esther. And she go like this, did you call me? It was funny. It was really funny. All right. With that, let's take about a 5-minute break. We'll come back, do the lab today, distillation. And then after I'm done, about 5 minutes or less, I'll send out the password for test number 2. All right, let's take a break. I'm back. No, I didn't run away. I had to find something for Dr. White's show and tell. But first, I need to open up a file. All right, now it's lab time. And today's lab is called distillation. And what is distillation? I got my hair, I gotta get rid of that. Don't look, there, it's gone. All right, today's lab is distillation. Now, distillation in organic chemistry is a way of purification. And what do you purify? Mixtures of liquids. If you have a mixture and they're a liquid, you can distill it. How many of you ever heard of moonshiners? And the device they use to make their liquor, moonshine, is called a still. And what they're really doing is a distillation. So today's lab, we're going to do distillation, purification by distillation. Now, if we are face-to-face, this is the handout I actually give without the data. When we're face-to-face doing this lab, I remind you, we're working with hexane, which is very flammable. Hexane is a minor component in gasoline, but the alkanes are quite flammable, the lower ones. So all waste go in a waste bottle, which I put out in a fume hood. And so how does distillation work? Well, it relies on the fact that all compounds that are liquid are boiled. When a liquid of a compound boils, vapor pressure, that liquid, equals atmospheric pressure. And the temperature at which this happens is called the boiling point. Now, I have to warn you, I'm going to do some artwork. And if you want, laugh, but don't hurt yourself laughing too hard. If I were to take a beaker with water and put it on a hot plate, oh, it looks pretty good. Here's my electrical cord. But anyways, eventually you would see bubbles in here. And what are those bubbles? Those are, or they are, water vapor. Water vapor is another way of saying water as a gas. And those bubbles come to the surface and collapse, open up. They let that water vapor, water gas out. And the vapor comes up here. Any gas you can measure a pressure, we call it vapor pressure. And when the vapor pressure equals atmospheric pressure, abbreviated that way, if you had a thermometer and you put it in here, you can measure a temperature, and that temperature equals the boiling point of that liquid. In this case, it would be water. Now, something I need to teach you, and that is most and all of your life, when you boil something like on your stove to cook noodles, rice, or whatever you do in boiling water, or if you're making tea by boiling water, you're doing it in a metal pot or pan. And no matter how smooth you think the metal is in there, it's not. If you magnify it enough times, it looks like all these mountains and canyons. It's very rough, even though to your hand, it feels smooth. Now, in glass, even if you see scratches, that's really smooth. And why am I talking about this? Because these bubbles to form need a rough surface. If you don't have something rough in here, in a glass container or beaker, when you heat a liquid, it will bump. You'll get these monster bubbles that spray the liquid up. I've seen someone do a distillation where it bumped on them. I didn't see it. I saw the aftermath, and stuck the thermometer in the ceiling of that room. We let them know what an idiot that person was and how dangerous it was. So whenever you do a boil anything in glass, and this is important, you always add we call them boiling chips, or you could also call them boiling stones. Now the chips are usually marble. The stone, or I should say the stones are marble. The boiling chips are this inner metal called carborundum. I don't even know what that is, some sort of metal. And the carborundum are a little more expensive. At COD, we use the boiling stones. At ECC, we use the boiling chips. I like the chips better. Both work. And you only have to put about 3 or 4 in a container, beaker, or whatever you're doing your boiling, so it doesn't bump. If it bumps, it goes straight up, and you don't want that to happen. Now, in this case, when you boil liquid, vapor starts coming out from the bubbles, and the bubbles rise and collapse, and the vapor continues above the liquid. If you were to cool that vapor, you get back the original liquid. Now, when you slowly heat an organic compound that's liquid, the vapor will rise and the temperature will increase until it stays at constant temperature of that vapor. And that's the boiling point of a compound. When you have the vapor coming over and you measure the temperature of the vapor, when it's steady, maybe moves a half a degree, but doesn't move 5 or 10 degrees, that's the boiling point of a compound. Now, here's one apparatus. We use a different one. And you have a round bottom, a head, condenser, and a way to measure, trap, contain your liquid. I used that picture. But anyways, hold on one second. Be more than 1 second. I'm trying to find no lab where I had actual pictures of it. Found it. All right, you see on your screen the picture of the thermometer and other things I have here? This is a distillation apparatus. At the bottom, we use what's called a round bottom flask. You have a distillation head and a thermometer adapter. Now, a couple of years ago, Dr. Daly, who's doing a great job as lab manager along teaching 2-semester organic at Elgin Community College, with my suggestion, his help, we were able to purchase thermocouples that now you have a digital readout. It's easier for the students. And then here we have a condenser. Now, in the round bottom, right here, you have what you're going to distill. You don't see it, but you have a couple boiling chips right there. That's so it doesn't bump. Now, when you go at home to make noodles or rice in a pot of boiling water, do you put the water all the way to the very top of the pot? No, because when it starts boiling, it will go out over the side of the pot. I've seen people do that where well, as one of the greatest mentors I had always used to remind me, common sense is not common. But anyways, the same thing is true when you're filling and doing distillation. You never go to more than 2/3 full, because if not, it will boil over and you won't get a purification. So you put in boiling chips so it doesn't bump, because otherwise the liquid would come all the way up here, and that's not what you want. You just want the vapor. Now, another important safety thing, which I remind students, you never let this go to dryness. You never let that go to dryness. It becomes dry. Why? Because then you're going to overheat any residue in there and it can explode, which is not a good thing. I've never had that happen to me or in a class, but that's always a safety concern. So safety, 1, always put boiling chips in or you can get bumping. 2, never fill the round bottom more than 2/3 full, because it will boil over, just like a pot of water that's full to the very top. And you never let that go to dryness. Now, here's a condenser. And you have an outer water jacket and an inner tube, and they're separate. What happens is water comes in here and comes out here, and you use cold water from a tap. We have this in our hoods. That fills this whole outer tube with water all the way up to here. Now, on every science fiction movie I've ever seen, they do it backwards. And it's important to remember, water goes in the bottom, if I can spell, always goes at the bottom. Because if you put it in at the top, only this part would get full. You wouldn't fill the whole outer condenser here and here with water. So it always has to go in at the bottom. And if you look at a lot of science fiction movies, they always have it going at the top. And if I'm with friends in a movie and they say, "Why are you laughing?" They've got that set up wrong. Because I'm the only chemist, organic chemist, with my friends who are watching that movie. Now, when this is all connected together, now right here, this is called the ground glass joint. And you put some lubricant on there so it doesn't get stuck, but that forms a vapor-proof seal. So you can put this together. Now, our lab, and then underneath, will have, it looks like a little electric blanket, but shape. It's called a heating mantle. And you connect that not directly to the wall, but through a variac controller. That slowly heats this up. And it heats up, you start getting bubbles, and the vapor comes up here. This is all together, and it goes this way. Now, because the vapor will also get up here, you can read the temperature, and we have actually a digital. And when the vapor goes in the condenser, it becomes a liquid. You see drops of it as an actual liquid. And you go through the Claisen adapter, condenser adapter, and the liquid starts dropping, and you'll have a graduated cylinder that you can measure volume. And you do this slowly. And if you had two different liquids, the lower boiling comes off first, and you can do what's called a fractional distillation. This lab is just to give you an understanding of distillation. Now, what we'll do is you'll add about 7 milliliters in the smaller scale to your round bottom. This is the wrong lab. I apologize, I opened up the wrong lab. Let's go to this one. Never let it go to dryness. You'll distill it, stop your distillation. You'll put in 30 milliliters of hexane in the round bottom. Use a funnel. Always use a funnel to put liquids in a round bottom. You put about 3 or 5 boiling chips and use what's called a powder funnel. And I ask people, before you plug anything in or turn on the water, have me check it. Now you have rubber or Tygon tubing. If you turn the water all on, that tubing pops off and it's like a hose or snake, and you get a bath or a shower real quick. And then once I check that, I say, all right, go ahead, start heating it. I say what setting, about 3 or 4 on the controller, and you'll collect the, I got the wrong lab here too, the one on D2L has data in here. Let's see something. Huh, I'll have to check and make sure I have it. But anyways, if you were doing it in the lab, you'd have a graduated cylinder, and at every 2 milliliters, you'd look and say, what's temperature? And when the temperature is leveled out, that's the boiling point of the hexane. Now, normally you wouldn't distill the hexane, but this is more giving you an understanding of distillation, which you now have. Now it's time for show and tell. Now, if you look at when I have my video, my camera off, if you look on your screen now, you'll see this image. What is that? Well, in graduate school, I did a lot of distillations to make compounds pure. And we use small little, this is called bantamware. Isn't that cute? I got this stuff on eBay after years later. So I like a memory of good times. And here's the special distillation head I use. These are expensive. I got this one used from eBay years ago, new. And you notice it's got this, oh, isn't that cute, tiny little condenser. And the inside, you'll see a tube there. And what you do is you have this like this in here, and I didn't buy one. You buy a thermometer that has a glass joint and will be right around here. And the vapor comes up, water in the bottom, out the top, comes here, and you can collect it and distill it. And this is my friend. It was in grad school, not this one. No, I didn't steal anything from Michigan State. But when I saw it on eBay, I immediately bought it. And I'm happy. Now, if you notice this right here, this allows you to pull a vacuum. And that's called a vacuum distillation, which we don't do. It's ECC. But since the boiling point is when atmospheric pressure equals vapor pressure, you lower the pressure it is, not really the atmosphere, but the pressure in the round bottom you're receiving it, that lowers the boiling point. And some chemicals, if you heat too high, they decompose. And by doing a vacuum distillation, they distill at a lower temperature. And with that, I'm done. Answer the questions. Don't forget there was a lab due today. And in about 5 minutes or so, maybe a couple minutes more than that, I will send out an individual email to each of you with the password. Remember, always the password is lowercase. With that, if you have any questions, come to my office hour tonight, email me. Remember, get it uploaded as a single PDF file. You don't have a printer. By the way, it's a nice black and white HP printer. I think I got it's almost 2 years ago for about under $200 from Staples. And it's been really good. It's also a scanner. You don't have a scanner, you know how to make a PDF file with your cell phone. With that, I'll say goodbye, gang gesund. Have a nice rest of the week and weekend. Remember, I stole that from Granny and Beverly Hillbillies. And gang gesund means in Yiddish going, oh, gang gesund, goodbye.